Alright, this is chapter 1 homework. Let's start with 1-6. We have function machines, and the output of the first becomes the input of the second. So if a number comes out here, it goes into the other one, or vice versa. In what order must you put the machines to get a final output of 5? Let's say your initial input is 6. Let's just guess. Let's drop 6 into this machine. So when it comes into this machine, the 6 gets squared, and then it subtracts 6. 6 to the power 2 is 6 times 6, or 36. Oops. And then 36 minus 6 is going to be 30. So that 30 is the number that gets sent up top, and it gets dropped into this function machine. It takes the square root of the number, subtract 5. So the number was 30 now. 30 subtract 5 is 25, and square root of 25 is 5. So that works. We got a final output of 5. So the order is y equals x squared minus 6 first, then y equals square root of x minus 5. Okay, you can try B. Let's move on to 110. This is evaluating, so let's plug in x equals 2 into these equations. I'll do A and B. We have y equals 7 minus 3 times x, and x is 2, so it's 7 minus 3 times 2. So that's going to be 7 minus 6. 7 minus 6 is 1. B. Y equals, we have the input, or x squared, and then subtract 1 from that. So it's going to be 2 squared, which is 4, and then subtract 1 from that, that's 3. Alright, you can try C. Let's go on to 1-15. Draw figure 4 below. I like to shade these things. So as you can see from figure 2, those 4 tiles get added. So we're adding on 4 tiles. And then to figure 3, those 4 tiles are new. So we're adding on 4. So that's the pattern. There's 6 tiles in figure 1, 10 tiles in figure 2, and then if you count up figure 3, that's 14. So if you look into the future, if the pattern continues, it's going to be 4 more tiles for a total of 18. So figure 4, let's draw it below. It's going to have 2 tiles right here, and then it's going to have these little arms that come out. And you notice 2 new tiles get added on each arm for the next figure. So we have 1, 2, 3, 4, 5, 6 in that one. 1, 2, 3, 4, 5, 6. So we're going to have 2 new tiles on each arm. And so these 2 are the ones that are added. And just to double check, we should have 18, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Alright. You can try B, just follow the pattern, go to figure 10. Plus 4, plus 4, plus 4. Okay, 1-16. I'll do B, and I'll do C. Okay, so for B, on the left side, 2x minus 6. Those are not like terms. But on the right side, I have a 3x and a minus x. And a 3x minus x makes 2x. I also have plus 1 minus 7. 1 minus 7. It's actually negative 6. So, as you can see, I have the same thing on each side. And if I try to remove identical x's on each side, minus 2x, minus 2x, those make a 0 pair, and those are gone. So the answer here, all real numbers. Remember, when x is gone, and this is true, it's all real numbers. If it's different on each side, then it's no solution. Alright, C. And it doesn't say to check, so that's it. Alright, C, I need to get X alone. I'll start by subtracting 1 on each side. 1 minus 1 makes a 0 pair, that cancels. And 43 minus 1 is 42. Now I have 3 X's. I'm going to divide both sides by 3. 3 divided by 3 cancels, and I just have X on the right side. That's going to be 14. X is now alone, so that's the solution. X equals 14. Alright, 124, we've got some function machines. If an input of -9 is put into each of the machines, what is the output? Alright, let's talk about this one first. We've got y equals, 9 goes in for x. Don't forget, when you plug in a negative number, you put it in parentheses. So it's -9 squared, or -9 times -9. A number squared is a number times itself. So 9 times 9 is 81, and then negative times negative is positive. So we have 81 plus 3 for 84. If we try this one, take the square root of a number, and then subtract 2. The input is -9, so we're taking the square root of -9. And that's actually not possible. So for the one on the left, the output is 84, and the one on the right, not possible. The reason, you can't square root a negative number. That is not allowed. Can't square root a negative number. Alright, so that's A. You can try B. Let's look at 132. We're supposed to graph this. Jump height and someone jumping on a trampoline. Let's graph this. So on the x-axis, let's call that our jump number. And then on the y-axis, that's going to be our height in feet. Alright, jump number 1. So you find 1 on the x-axis, and then you go up by 0.5. Jump number 2 is 0.9, so it's almost 1. Jump number 3, find 3 on the x-axis, you go up by 1.6. 4 is 2.9, and 5 is 5.2. So that's the pattern there. Now how do we describe this data? Well, number 1, from left to right, it is increasing. Number 2, that's not a straight line. You can't draw a line through it. So it's curved. You could also say non-linear. It's just curved graph. This is the y-axis, and as you can see, there's no point on the y-axis. So that means there's no y-intercept. And we're going to do the same thing, intercept. We're going to do the same thing on the x-axis. So if you look on the x-axis, there's no point on the x-axis. There's no black dot there. So what we can say is there's no y-intercept, no x-intercept. You might also notice that there's no negative values. That doesn't really make sense. We're jumping up in the air. No negative jump heights. If it were negative, you'd be jumping underground. And then I'll go ahead and do C. No, I'll let you guys do that. C. What would be like a maximum and minimum? Answers may vary on that one. Let's go on to 138. So for 138, let's look at B and D. Alright, for B, try practicing with function notation. So f of 2, the input is 2, and it's equal to 3 raised to the power 2 plus 1. So 3 raised, I put parentheses here just because I'm plugging the number in, but that's 3 squared. So it's 3 times 3, 3 squared, which is 9 plus 1, that's going to be 10. So f of 2 equals 10. D. F of 3 equals the square root of the input x minus 5. And our input x is 3. So 3 subtract 5 is negative 2. And you have to stop right there. And that's going to be no output or no solution. The reason being is you can't square root a negative number. You can't take the square root of a negative number. Alright, 1-39. I'll do B and C. So for part B, f of 3, this is our function. That's the rule. And then here's like an example we can follow. So f of 3 equals 2 to the power 3. That's an exponent. And 2 to the power 3, that's 2 times 2 times 2. 2 multiplied by itself 3 times. So that's going to be 8. F of 3 equals 8. C, we have a t inside the parentheses. Let's go ahead and plug that in. So instead of 2 to the power x, we're going to replace x with the letter t. And in fact, that's all we can do. We don't know what t is. We don't know what t is, so we leave it like that. That one's kind of weird. Alright, 147. We've got 4 of these, so I'll go ahead and do A. And I'll do C. Let's start with A. Which of these are functions? If it's not a function, give a reason. In class, we discussed the vertical line test. So let's look at this graph. If I can draw a vertical line, and it hits more than once, it's not a function. And as you can see, that vertical line hit more than once. Not a function. It says to give a reason. So here's option A. Doesn't pass the vertical line test. You can also say that there are inputs with more than one output, which is not allowed for a function. So there are inputs with more than one output. If you're kind of confused what that means, this line is kind of like the input line, and then each dot is an output. So for an input of, say, x equals 0, this is 0, right? So for an input of 0, there's actually 2 different outputs, 2 dots. Output, output, not a function. So either one of these is fine. You don't have to put both, just pick the one that makes the most sense to you. And let's do C. Alright, so C, this is kind of like our vending machine example. When you press button 7, the output is 10. When you press button -2, the output is 0. So we're looking for repeats, and there's 2. There's a repeat in the output, repeat in the input. But here's the problem. The input 7 has 2 different outputs. Which are 7 can output a 10, 7 can also output a 3. 10 and 3. So for that reason we say it's not a function. There are repeats in the output, but that's okay. Repeats in the output doesn't matter. It only matters, we're only looking for repeated inputs. Inputs with 2 different outputs. Alright, 149. Find the growth rate of the pattern. I like to shade in the new tiles in each figure. So figure 2 has 1, 2, 3, 4, 5, 6, 7. 7 tiles. And then figure 3, you can see that we added these 2 to the figure. So if you add 2, I don't even have to count. Add 2, it's going to be 9 tiles. And then for figure 4, you can see that from figure 3, the only new tiles are those 2. So that's another plus 2 for a total of 11. So the growth rate is 2 tiles. Alright, I'll let you guys figure out B. And actually C doesn't seem too bad, so give it a shot. Let's go on to 1-50. Okay, for 150, we're trying to solve these equations. This one has some fractions. I'll help you out with that one. And then, what else can we do? I'll do A. Alright, so for part A, we always look to combine like terms first if we can. On the right side, we only have 10. Can't combine like terms. But if you look on the left, there's a 6, there's a -3. And 6 and -3 make normal 3. So a normal 3 minus x. Alright, now we want to get x alone. So the next thing I'm going to do is take away 3 on both sides. Make a 0 pair. 3 minus 3 cancel. 10 minus 3 is 7. And be careful because negative x is still there. Now there's a move where you can flip everything upside down. So negative x becomes normal x, 7 becomes -7. And that's the answer. You can always plug it back in to check, which it says you should do. So let's do it this time because it says so. 6 minus x minus 3 equals 10. So 6 minus x. X was -7. So we're actually doing 6 subtract -7. And when you have 2 minus signs, it becomes a plus. So it's 6 plus 7 minus 3 equals 10. 6 plus 7 is 13. 13 minus 3 equals 10. Looks good. There's our solution. Now let's do C. Okay, so for part C, we have a fraction. We want to get x on one side, and right now x is on both sides. So here's what I'm going to do. I'm going to pick the smaller x. I've got a 1x and a third x. So I'm going to pick this one. And I'm going to make a 0 pair. I also have to subtract that on the other side, so I'll take away 1/3 x from both sides. On the left side, that's easy. That's a 0 pair. It cancels, leaving 4. And on the right side, if I have 1 and I take away a third, how many are left? 2/3, right? 2/3 x. So 2/3 x minus 2. Alright. Getting x alone, I'll add 2 to each side. There's a 0 pair, that's gone. 4 plus 2 is 6. 6 equals 2/3 x. So at this point, you can think of it as 2/3 of what number would be equal to 6. And if you're good with math, maybe you know that's 9. However, there's also a different way to do it. So if you divide both sides by the number in front of x, you're actually dividing by 2/3. So this is going to get crazy. So these 2/3 cancel, leaving x. On the left side, we have 6 divided by 2/3. Now I forget when they teach this, but when you divide by a fraction, what you do is you turn divide into times, and then this guy goes upside down. So 6 times 3/2 equals x. This is kind of like method B. Alright, now, when you multiply a number times a fraction, you put the number over 1, and then you multiply straight across. 6 times 3 is 18 over 1 times 2, that's going to be 2. And 2 goes into 18 9 times. So you can see that either way, it actually worked out. we still need to check. So let's check. I have 1/3 x plus 4 equals x minus 2. So that's 1/3 times 9 plus 4 equals 9 minus 2. Alright, using that same strategy, put the 9 over 1, multiply across. 1 times 9 is 9, 3 times 1 is 3, and then add 4 to that. 9 minus 2 is 7. Okay, 3 goes into 9 3 times, and 3 plus 4 is 7. Answer is correct. Alright, let's give 1-59 a shot. You guys can figure out A. I'll help you out with B and C. So for the domain, we use the cover-up method. So this is how far left the graph goes, and this is how far right the graph goes. And as you can see on the left, it's -6, 2, on the right, 6. So domain, you always describe the graph from left to right. How far left does it go? How far right does it go? And since we're along the x-axis, a more advanced way of writing this would be using inequalities. So you don't have to write it like this. This is kind of like the advanced way. One or the other, pick whatever way makes the most sense to you. Now let's do range. And range is going to be how low does it go on the bottom? How high does it go on the top? So if you draw a line on the bottom, that's going to be hitting the y-axis at -4. And if you draw a line along the top, that's as high as it goes, 4. So the range is -4 to 4. How low does it go to how high does it go? And then again, if you like the advanced notation, since up and down is along the y-axis, you can do it with inequalities, but that's totally optional. Okay. Next, f of 4. So I'll do C and D. The number inside the parentheses, that gets plugged in for x. So it's like saying x is equal to 4. So f of 4 is equal to 3 times 4, subtract 12. So plugging in 4 for x, 3 times 4 is 12, minus 12, which is 0. So f of 4 equals 0. Part D. Same input, find f of 4. And that's going to be equal to, we got in parentheses our number minus 2, then we're going to cube it and subtract 6. So our number minus 2 is 2, right? 4 minus 2 is 2. 2 cubed minus 6. And 2 cubed, that's 2 multiplied by itself 3 times. And then take away 6. 2 times 2 times 2, that's going to be 8. And take away 6. 8 minus 6 is 2. F of 4 for part D is equal to 2. That's the output. Okie dokie. Let's go on to 168. Start with A. You can use the law of exponents, or you can rewrite it. So I'll do it both ways. On the top we have 11 H's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. On the bottom we have 9 H's. 1, 2, 3, 4, 5, 6, 7, 8, 9. And these are all multiplying. When you have exponent, it means repeated multiplying. And let's see which ones turn into 1. Cancel, cancel, all of these turn into 1. They're all multiplying each other, but when they become divided, they cancel out. So the only thing that's left is h times h divided by 1. H times h is h squared, and any number divided by 1 is itself. Now the shortcut method is when you divide two terms with the same base, you write it as a single base, and the exponents subtract. So there you go, method A, method B, same answer. Alright, how about E? That looks difficult. So for part E, the coefficients, or the numbers in front, I'll put those in their own fraction, times, I'll give the x terms their own fraction, times, and I'll give the y terms their own fraction. I've got y to the power 3, and since there's no other y on the bottom, I'll put it over 1, because any number divided by 1, that's not going to change. Alright, so 16 divided by 2 is 8. X to the power 4 divided by x to the power 4. Any number divided by itself, that's the giant 1. So it's 8 times 1 times, and then y to the power 3 divided by 1 is itself. So there you go. It's not too bad. 8 times 1 is 8 times y cubed. And you don't have to write the times sign for y cubed, you just write the numbers next to each other. A number next to another number means multiply. Alright, let's go C. C, when you have an exponent outside the parentheses, that tells you how many times to multiply the parentheses by itself. So 3k to the power 5 squared means 3k to the power 5 gets multiplied by itself twice. So let's expand. This is 3 times 5k's, and then we'll multiply by the same thing, 3 times k times k times k times k times k. Kind of out of space there. Alright, now we are allowed to rearrange, so that's 3 times 3, and then there's going to be 10 k's, right? 3 times 3 is 9, and then the k's make k to the power 10, because there's 10 of them now. Alright, you can try B, D, and F. Let's go on to 1-69. I'll do A here. Haley simplified this and got that. Lacey simplified this and got the same answer. Let's see who's right. So when you have x to the power 3 times x to the power 2, that's going to be x times x times x. There's our first 3 x's, times, we've got 2 x's there, so that's times x times x. 2 more, for a total of 5. That's x to the power 5. Haley is correct. So let's see what Lacey did. Lacey did x to the power 3 plus x to the power 2. Now these are not like terms, so you can't combine them. And the reason you can't combine them is that plus sign. Exponents have to do with multiplication, not with addition. So Lacey is wrong, these are not like terms. Adding doesn't lead to the laws of exponents. Alright, you can try B. Let's go 1-70. I'll do 2 of these. So let's start with A. 62.5 times 10 to the power 3. This is not in scientific notation, because this number in front should be from 1 to 10. And 62.5, it's bigger than 10. So here's what I'm going to do. We've got 10 to the power 3 is times 10 times 10 times 10. And what I need to do is, first of all, point out that 6.25 times 10 equals 62.5. And I know that because when you multiply by 10, all you do is move the decimal over. So I can actually replace 62.5 with 6.25 times 10. And then I still have these 3 times 10s. And I did that because this number is now from 1 to 10. So 62.5 becomes 6.25 times 10. And here's my answer. 6.25 times 10. And there's 1, 2, 3, 4. There's now 4 10s. Okay, next, let's look at C. I've got 0.39 times 10 to the power 9. So there's going to be 9 of these 10s. 9 10s. Now, I know that 0.39 times just one of the 10s will force the decimal to move to the right one time. And that's the problem, same problem with part A. That's not a number from 1 to 10. 0.39 is too small. Okay, so if I multiply one of them by 10, I get 3.9, and that's good. But that 10 has now been combined into the number, and there's 8 10s left. So there's still 8 10s over here. One of the 10s went to making 0.39 into 3.9. Alright, I think this is the last one. Cool. Let's do 2 of these and call it a day. I'll do C, I'll do D. Okay, for part C. Remember, with equations, you always look to combine like terms on each side. So on the left, I've got a 4x plus x. It's going to be 5x. There's a minus 2 left over. On the left side, no like terms. Okay, then I look for the smaller x, which is this one, and I make a 0 pair. So minus 2x. 2x and minus 2x, 0 out. A number minus itself, that's 0. 5x minus 2x is 3x minus 2. And all that's left on the right side is minus 2. Okay, so in order to get x alone, I need to make a 0 pair. Is that plus 2? Negative 2 plus 2? That's nothing. Or 0. Leaving 3x on the left. On the right, negative 2 plus 2, that's 0. Leaving nothing. Alright. Now I'm going to divide both sides by 3. And 0 divided by 3 is 0. A lot of students will write undefined, but that's wrong. Some people write no solution. That's also wrong. It's 0. And the reason it's 0 is, think about that last part. 3 times what number is equal to 0? It's 0, right? 3 times 0 is going to be 0. So our solution is not undefined. It's 0. And it doesn't say to check the equations, so I'll stop there. Last one, part D. Combine like terms on each side. I've got 3x, and then negative 4 plus 1. Negative 4 plus 1 is negative 3. On the left side, I've got negative 2x and 5x. 5x minus 2x, that's going to be 3x. Okay. I can kind of tell this is going to be a special case because you have 3x on both sides. So when you make a 0 pair with one of the 3x's, both of them become 0 pairs and vanish. And let's see what we have left. We have negative 3 and negative 5. So when it's different on both sides, x is gone, it's different on both sides, it's no solution. This is an equation, and negative 3 is not equal to negative 5.